We'll continue reviewing calculus 2. Find the linear approximation for the function centered at 4. So this is a simple version of the Taylor series. So it is linear, so we only take up to the first derivative, the formula over there. So this is a function, we take derivative and then substitute 4 into the function and then into the derivative, and that pretty much it. Right, so this is the function, so the derivative, the function is x plus 1 over x, or x plus x to negative 1. Derivative of x is 1. Derivative of 1 over x is negative x to negative 2. Or we have 1 minus 1 over x squared. Right. Once again, f of x I will rewrite as x plus x to negative 1. So derivative is that. Right. Now we just need to substitute 4 into the function and derivative. The function at 4 is 4 plus 1 over 4. So that's 16 over 4, 17 over 4. And then the derivative. Put 4 in here. So that 1 minus 1 over 16, so that 15 over 16. And the linear approximation. Or this one, we want the linear polynomial, meaning that this is the polynomial degree 1. And the formula I said is over there. When a is equal to 4, so we have f of 4 plus derivative at 4 and x minus 4. Right, so f of 4 is 17 over 4 plus the derivative 15 over 16 x minus 4. Right, I'll multiply this out. 17 over 14 plus 15 over 16. 4 and 16 cancel out. We have 15 over 4. Right, and 17 over 4 minus 15 over 4, that is 2 over 4, which is 1/2. So we have P1 of x, the linear polynomial that approximates the function. The 1 here denote the degree is 1. I forgot an x here, right? 15 over 16x. Again, 17 over 4 minus 15 over 4 is 2 over 4, which is 1/2. Right, so that is that. Next, find the Taylor polynomial order 3 standard 0. For this, we can use the formula up to the order 3, so up to third degree, so will be that. However, for this we just construct the table as we did in class. So we make a table. This is up to degree 3, so we have 0, 1, 2, and 3. That is k. And first we have the k derivative. And then we evaluate. This is center at 0. And then we divide by the factorial. Right. First we have e to the negative 2x. Derivative of this is negative 2 e to the negative 2x. And the derivative of that is another negative 2. That's 4 e to negative 2x. And another one is negative 8 e to negative 2x. Now we evaluate this as 0. E to negative 2 times 0. E to the 0 power is 1. Negative 2 e to, once again, e to 0 power is 1. So this is negative 2. And e to 0 power is 1, so this is 4. And this is negative 8. We divide that by the k factorial. 0 factorial is 1. One factorial is also 1. And 2 factorial is 2. And 3 factorial is 6. Right. So this is what we have. This is order Taylor polynomial order 3. So we write P3 of x. Right, 1 times x minus the center to the 0 power. And then minus 2 x minus 0 to the first, and then plus 2 x minus 0 square minus 4 over 3 x minus 0 cubed. Of course the center is 0, so we write that x minus 0. And this simplified to x minus 0 is x to 0 power is 1. So have 1 minus 2x plus 2x squared minus 4 over 3x cubed. Right, so that's what we have. Of course, we can also use the table for e to the x here, over there, and all we do is just substitute 2x, negative 2x into this x on each of the x in that Taylor series, and we could have the same thing. Right, find Taylor polynomial order 3 generated by this function at a. Of course, we can make the table the same way. I will rewrite the function before I do that. I'll write x plus 5 to negative 1. Right, so actually there are a couple ways to do this. I'm just going to use a table like we did here, and then I'll show you another nicer way to do it. Right, construct a table. Now this is centered at 1. Right. So the original function is x plus 5 to the negative 1. Derivative of this is negative x plus 5 to negative 2. And then we also have derivative of inside the parentheses. Derivative of x plus 5 is just 1. So that's why we don't have to do much. This is what I mean. We have something to negative 1 and we take the derivative of that. So that means it is negative the parentheses to negative 2 and then derivative of the parentheses. So in general, that's how it is. And now the function inside the parentheses is x plus 5. And this is just 1. So conveniently, that's all we have. Then we take the negative 2 down, make it 2, and then x plus 5. And then the derivative of x plus 5 once again is just 1. And then take the negative 3 again. Right, that's what we have. Now we substitute 1 into all of this. 1 plus 5 to negative 1. Well, that is 6 to negative 1. 1 over 6. Right, 6 to negative 1, 1 over 6. Negative 1 plus 5 to negative 2. Negative 6 to negative 2 is negative 1 over 36. Next, 2, 1 plus 5 to negative 3. We have 2 over 6 cubed be 216. We'll cancel out later. I just want to keep it like that. Of course, a 2 and 116. That is. Next, negative 6. X is 1. So you have negative 6. And 1 plus 5, 6 to the negative 4. Move to the bottom, become 6 to the 4th. Cancel this out, we have negative 1 over 6 cubed. 6 cubed is 216. Right, so that's what we have. Now divide by factorials. 1 over 6. Let's see how do we write this. One over 6 divided by 0 factorial, which is 1. So that's the same thing. Negative 1 over 36 divided by 1 factorial, same thing. 2 over 16 2 over 216, sorry, over 2 factorial. 2 factorial is 2, so you have 2 over 216 divided by 2 is multiplied by 1/2, which cancel out the 2's. We have 1 over 216. Next, negative 1 over 216 over 3 factorial, which is 6. Divided by 6 is multiplied the reciprocal, and 216 times 6 was 6 to the 4th power. 1296. And the polynomial, this once again order 3. 1 over 6, center at 1, x minus 1 to 0 power, minus 1 over 36, x minus 1 to the first, plus 1 over 216, x minus 1 square, minus 1 over 1296, x minus 1 cube. Right, of course x minus 1 to the 0 power is 1, and the rest will be pretty much the same thing. 1 over 6 minus 1 over 36, x minus 1 plus 1 over 216, x minus 1 square, minus 1 over 1296, x minus 1 cube. Right, so the notation is that P3 of x. Like I said, there's another way to do this. Of course, we can also use something similar to the geometric series here. Right, this is what I will write. Right, so we have 1 over x plus 5. Okay. 1 over x plus 5. What I will do is I will try to compare this to a geometric series of a r to the k, and this is equal to a over 1 minus r, as long as r is between negative 1 and 1. Right, so that's what we try to turn this into the right hand side here. Right, first of all, what we need, the problem gives us that is centered at 1, so we have to rewrite this as follow: x minus 1, so that we center at 1. We cannot just subtract 1 like that. We have to plus 1 to keep things balanced. And then some plus 5 here as well. So that will be 6. So we have 1 over 6. Of 1 plus 5, 6, and then plus x minus 1. Right, so almost there, except we need the 1 and we need to subtract. So what I do is I try to turn the 6 into a 1 here. So what we have, I will divide 6 on the top and bottom. So on the top is 1 over 6. The bottom, the whole thing divided by 6. 6 divided by 6 is 1. And we have x minus 1 over 6, like that. Now we do, so that looks like a is 1 over 6 and 1 minus r. Now we just need the minus here. So that's easy. All I need to do is just say this a plus is subtract the negative, x minus 1 over 6. Now it looks exactly this form. Now assume r is between negative 1 and 1. We can write this as a summation. For this one, a is 1 over 6 and r is negative x minus 1 over 6. Put everything in here. 1 over 6 for a, and r to the k. Or if you want to write the negative separately, that's fine as well. We have 1 over 6, the negative 1 to the k, and then we have x minus 1 over 6 to the k. Right. Now we want this up to order 3, so we just need to write from k up to 3. So when k equal to 0, put 0 in here for k, 1 over 6, negative 1 to the 0, x minus 1 over 6 to 0, and now put 1 in for k, and put 2 in for k, and put 3 in for k. Right. This to the 0 power, so this is just 1, so we have 1 over 6. This gives us a negative x minus 1, and then 6 and 6 at the bottom, so that's 1 over 36. And then x minus 1 to the first. Next, negative 1 square, that is positive. 6 here, and then 6 square. Okay, just want to write. That's, this is 1, this is negative 1. So we just have 1 over 6, and then x minus 1 square. 6 square is 36. So square of the top, square of the bottom. And negative 1 cube is negative x minus 1 cube, and then 6 cube. Right, simplify this, we have 1 over 6 minus 1 over 36, x minus 1 plus 1 over 216, x minus 1 square, and 1 over 1296, x minus 1 cube. Of course, we should get exactly the same thing. If we have this series, we can go as far as we want to. And so that is the series. But since we only go up to 3, so we start from here. Probably, I mean, this not the whole series are equal to. But if we only write 3 terms, we're just going to say approximately equal to, just 2. Because this series is going definitely approximately for the first 4 terms, we just write approximately equal to. But bottom line is that is still the same thing. Timestamp. Right, next, find the series radius of convergence. So for this, we just use the ratio test. For ratio test, I write out what is the term, and then we'll take the ratio of consecutive terms. So the term will be that. Right. Now the ratio test is the ratio of absolute values of the next term divided by this term. for this, at n plus 1, I substitute n plus 1 here, here, and there. X minus 4 to the n over n cubed 9 to the n. Right, with the limit. Now, divide is multiply reciprocal, and to n plus 1 I will split as x minus 4 to the n and x minus 4 to the first. The bottom, n plus 1 cube, this one we cannot split. The 9 to the n, we can do that, 9 to the n, 9 to the first. Multiply reciprocal, I'm just going to flip this. N cube 9 to the n, x minus 4 to the n. Right, multiply reciprocal. We can cancel out the x minus 4 to the n, the 9 to the n. What's left is x minus 4 to the first, which is x minus 4 and 9. The n cube and n plus 1 cube, I put them together. Right, let me put this as I have n cube and n plus 1 cube. Right, those two have n in it. What else is x minus 4 over 9? And now notice that this have n in it, x minus 4 over 9 doesn't have n in it, so we can just write that out separately. Also, since n go to infinity, that term is positive, right? If n goes to infinity, this will be positive. So we really don't need absolute values for this term. We do need the absolute values for this term though, for x minus 4. So that is the only thing we need the absolute values for. In this case, will be just x minus 4, because that potentially can be negative. 9 cannot be negative. The n cube cannot be negative. The n plus 1 cube cannot be negative. Right, that's what we have. Right, only need absolute value for that. And now, this is limit of n goes to infinity, right? So I'm just going to put a bracket here, not absolute values. Now, n go to infinity, this one have x in it, so it doesn't affect anything. What I will do, can take this outside of the limit. Because this have no n in it, so it does not affect the limit at all. Right. Yeah, if there's doesn't have n in it, we can take the outside as a constant. Same thing for derivative, integral, limit, summation. Right, now, this limit though, as n goes to infinity, n cube and n plus 1 cube almost identical, right? Infinity plus 1 is still infinity. Or another way to say this is n is significantly greater than 1, so we can just drop the 1 and we just have n cube over n cube. So bottom line is the whole limit here is equal to 1 as n go to infinity. Right? Because n plus 1, n is significantly like bigger than 1, we just drop the 1. N cube over n cube is 1. So from that, this is equal to x minus 4 absolute values divided by 9. So that is the ratio. Now the ratio test say that if the ratio, if that is less than 1, it is convergent. So we need this to be less than 1 to be convergent. And all we need to do is multiply 9 on both sides. If we multiply on 9 on both sides, we have x minus 4 less than 9. And so in this form, the 9 is the radius of convergent. Right. So if we want to find where it is center at 4, so we go 9 to the left and then 9 to the right. That gives us like positive 13 and negative 5. The 4 is the center. Right, but this question only asks for the radius of convergent, so that's what we do. Right. Next, we will find the interval of convergence. So this is one step further. Not only we find the radius convergence, we find the interval, meaning we have to check the boundary as well. I'm just going to leave that over there. Right. So once again, write out the n term. A sub n is equal to x minus 3 to the n power over 5 plus 5n. And write the ratio again. A sub n plus 1 over a sub n. Right, so that's n plus 1 and then over the same thing, a sub n. Just that. Right. Dividing fraction is multiply reciprocal. And we write x minus 3 to n plus 1 as x minus 3 to the n, x minus 3 to the first. And at the bottom, 5 plus 5 times n plus 1, that gives us 5n plus 5. So we can say 5n plus 10. Now multiply reciprocal. 5 n plus 5. Bottom is x minus 3 to the n. Yeah, multiply reciprocal. Now this cancel out. We have just x minus 3. Yeah, try to write small because this problem may be long. Alright, so we have x minus 3. I'm sorry, just put the n first. We have 5n plus 5. Bottom 5n plus 10. And then x minus 3 to the first is just x minus 3. That's it, actually. Right, now, like I said, the only thing that potentially be negative is x minus 3. The 5n plus 5 and 5n plus 10 as n go to infinity, they are positive. We don't really need absolute value for that. So like I said, we only need the absolute value for x minus 3. And that is a constant. By constant, I mean this x minus 3 does not have n in it, so we can take it outside of the limit. Right. Now, similar to the previous one, at n go to infinity, 5n is significantly bigger than 5 and bigger than 10. So we just have 5n on the top and then 5n at the bottom. 5n divided by 5n is 1. So this limit is just 1. Right, next. So the whole thing like that, we just have m limit at n go to infinity of at, okay, actually that's 1, so there's no more limit actually. Yeah, once again the x minus 3 doesn't have n in it, I can bring it outside, and the limit is 1, so we just have absolute value of x minus 3. And if we want to be convergent, ratio test, this have to be less than 1 to be convergent. Now I will draw the number line. We know center at 3. The radius of convergence is 1, meaning we go 1 unit to the left and 1 unit to the right. 1 unit to the left, 3 plus 1 is 4, and 1 unit to the right, 3 minus 1 is 2. So we go from 2 to 4. Right. Now, the only problem is we need to test to see what happened at 2 and what happened at 4, to see if it is convergent at the end point or not. So first we check at 2. When x equal to 2, I will substitute into the original series. And for x. Right, 2 minus 3 is minus 1. Right, now this is an alternating series. So I will write this. I write out the alternating factor, and then the rest I just say 5n plus 5, 1 over 5n plus 5 like that. Now, for the alternating series, call this is b sub n, or is that a sub n? It doesn't matter. It's okay. Just call the term that without the integration factor. And alternating series test, we will test two things. First, is that increasing, or is a sub n non-increasing? And second, what is the limit as n go to infinity? If both of them check, it is convergent. Right, so that is the function. Obviously, it is decreasing. The bigger values for n, The bigger the bottom, smaller the quotient. This one getting smaller as n getting bigger. So yes, we say h of n is decreasing as the denominator getting bigger. Is the limit equal to 0? Well, this one also yes. Like I said, bigger the bottom, smaller quotient, and when n go to infinity, this go to 0. So we have the finite divided by infinity, which is 0. So check. So it is convergent at 2. Right, so for convergent, it is convergent at 2 as well. Now we're going to test for 4. I'll put 4 in for x. And for my 3, just 1. Right. At 1 raised to any power, still 1. Right. So this, of course, we can say that is if look like this the p series when p equal to 1, so that is divergent. But the proper way to do this is let this series be h of n. So h of n is that, and we have b sub n. Pretty much as this, except I just have the one with the highest power, so we just have 1 over 5n. Right, so take the highest power when we do the limit comparison test. Or for this, I can just say it 1 over n, because the 1 over the 5 doesn't have n in it, we can bring it outside. So this is like just like what we did earlier. The x doesn't have n, and this doesn't have n in it, so we can take that outside. Same thing here, the 5, we can take that outside as well. Now this part by itself is divergent because p series and p equal to 1. Now next we just said the ratio of an and bn, just like the formula over there, have to be greater than or equal to 0 and less than infinity. So we have ratio of an over bn as n go to infinity. Right, a sub n, b sub n, one over 5n plus 5, and then b over 1 over 5n, multiply reciprocal 1 over 5n plus 5 times 5n over 1. Now, it is just 5n over 5n plus 5. But this is equal to 1. That means the behavior of a sub n and b sub n are the same. Since b sub n is divergent, a sub n is divergent as well. So it is divergent. at x equal to 4. Right, so this is the limit comparison test. The limit is equal to 1. That means behavior of a sub n and b sub n, the two series are the same. And b sub n already divergent, so a sub n is divergent as well. So we go back to, and we say the interval convergent. There's an including the 4, including the 2, and between 2 and 4. So we're going to say including the 2, but not the 4. Or we can write as the interval notation can be equal to 2, but cannot equal to 4. So this is the answer. That is the interval of convergence. I have to pause the video because this problem looks almost the same as the other one, so the answer could be similar. So what I do is I make one change here. Yeah, just that. Right. Now, same thing. I'll use the ratio test. First, a sub n is going to be that term. Right. A sub n plus 1, so that x minus 1 to n plus 1 over 5 to n plus 1 over x minus 1 to the n over 5 to the n. Actually, this is, we can just use geometric series. Oh, right. So I have x minus 1 to the n plus 1 is x to the 1 to the n times x minus 1 to the first. Divide by 5 to the n, 5 to the first. Multiply reciprocal 5 to the n, x minus 1 to the n. And cancel this out as well. So we just have x minus 1 over 5. Of course, this doesn't have any limit. This one doesn't have n in it, so the limit or not, it doesn't matter. So this is equal to x minus 1 over 5. We just have x minus 1. We only need absolute value for x minus 1, and then over 5. The reason we don't have the limit anymore because the limit, the variable is n, and we don't have any n in it. So that would be itself. So just I ask you, what is a limit at x go to infinity of 2? Of course, there's no x in there to substitute, just 2, right? Same thing here. There's no n to substitute in. And then finally, absolute value is only required for x minus 1 because the 5, it is positive. We don't need that. So this have to be less than 1 for it to be convergent. Right? So we have x minus 1 of absolute value of x minus 1 less than 1. Multiply 5 on both sides. We have x minus 1 less than 5. So 5 is the radius of convergent. So now let's draw it out. The radius is 5 and the center at 1. So if we want to go 5 units to the left and then 5 units to the right, 1 plus 5 is 6. 1 minus 5 is negative 4. So we know it's convergent between negative 4 and 6. Right. Now we just need to check what happened at negative 4 and what happened at 6. At x equal to negative 4. I put negative 4 in here for x. Negative 4, negative 1, that is negative 5 to the n, no 5 to the n. Negative 5 to the n we can write as negative 1 to the n times 5 to the n. Right? Yeah. Negative 5 is negative 1 times 5. Now we cancel this out. And we have n that's negative 1. And for this we will use the divergence test, because as n go to infinity, the sequence, the term does not go to 0. If the term does not go to 0, it cannot be convergent. Of course you can use alternating series test as well, because this is alternating and that does not go to 0 either, so it is divergent. So limit of that term as n go to infinity does not exist, meaning divergent, so it is convergent. I mean divergent at x equal to negative 4. It does not exist, but for sure it's not going to be 0. Divergent test say that if the n term does not go to 0, it cannot be convergent. It have to be divergent. So we know that divergent is negative 4, so negative 4 doesn't work. I'm going to put an empty circle at negative 4. Now as x equal to 6, put 6 in for n. So that's what we have. Now this one we show is going to be infinity. Why is that? because think about this. It is divergent because the n term does not go to 0. Furthermore, what we say is this series is equal to, so when n equal to 0, we have 1. When n equal to 0, we have 1. When n equal to 1, we have 1. When n equal to 2, we have 1. So just 1 plus 1 plus 1 all the way to infinity. So that's why this is equal to infinity. So it is divergent. So the 6 is not convergent. It's divergent at 6, divergent at -4, only convergent in between. So we say interval convergent. We can say it is from -4 to 6, and not including the 4 and not including the 6. Right, so that is what we have for that problem. Next question says that use geometric series that to represent this. Of course, we have the formula, and when we have the formula, just make sure that it is in the right form so we can use the formula. So the form has 1 on the top, all right, and then we have 1 at the bottom, subtract something. Right, so the first thing we do is take care of that. This has to be 1 here. So what I do is I have to divide by 2, top and bottom. And 2 divided by 2 is 1. 3x divided by 2. Let's write that. Right, like that. Yeah, now it is in the right form. Right? But actually, let's just make one more adjustment. I bring the 1/2 in front. Now, that part itself will be just like that. Right? So that means we have 1/2, and then the summation. To x to the k power, so that's just, this is x here. Just like that. Yeah, if we want to, we can just distribute the k into everything. That k power going to power of 3, power of x, and power of 2. And the 2, if we multiply at the bottom, 2 to the first times 2 to the k, that gives us 2 to the k plus 1. 3 to the k, x to the k, 2 to the k plus 1. Right, so once again, that is a formula. Make sure it is in the right form before we use it. Right, next, use power series operation to find Taylor series center at 0 for a given function. Right, for this, we just go to the Taylor series for sine of x. Sine x is equal to this. So either we use the summation or we can use the expanding form. But for this, we just have the series of for sine x. Sine x. If we're going to write out, it will be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Sine is an odd function, that's why it have all the odd power, right? First, third, fifth, and so on. Now, sorry, we still have x to the 6th and the sine x, I will use the summation k equal to 0 to infinity negative 1 to the k x to the 2k plus 1 all over 2k plus 1 factorial. Now just multiply the x to the 6 inside, so give us x to the 7, x to the 9, x to the 11, or in summation multiply the x here. 2k plus 1 is the power of x, 6 is the power of x. I add the power 2k plus 1 plus 6. And then over 2k plus 1 factorial. I mean 1 plus 6 is 7. Right. The reason I noticed this because this should still be an odd function because we have all the odd powers here. So this should have the odd, should have the power. So that should be 7. Sorry. Yeah, 6 plus 1 is 7. Right, so that was that. Next we have x to the 6. One again, x to the 6 and then 1 plus 6x. Alright, so this, if we looked, we can either use this one instead of x. We're going to use 6x, or we can use this one as well. So bottom line is one of those two. If we take out the x to the 6, so if we write like that, and once again I'm going to use this series representation. For that. Right, so x to the 6 still there. Now the series, instead of x in the formula I use 6x, so we have 1 minus 6x plus 6x square. I'm just going to write one more. That will be minus 6x cubed, and then so on. Yeah. So instead of x, we put 6x in there. Now in the summation form, it is negative 1 to the k 6x to the k. You put the whole 6x in the parentheses, and then of course k goes from 0 to infinity. And I just multiply this x to the 6 inside, x to the 6, 6x to the 7. This is 36x squared and x to the 8. And that to 16. X cubed and x to the 9. X cubed and x to the 6 is x to the 9. Or in summation form. So the answer is either that or that. I will split the summation. We have 6 to the k and then x to the k. If we split the 6 to the k and x to the k and then multiply by x to the 6, so plus 6. Right, so 6x to the k here is 6 to the k, x to the k, x to the k times x to the 6 is x to the k plus 6. Then we have e to the 5x. Well, e to the x is this. So if I write out, instead of x in the formula, I have to write 5x. So 1 plus 5x plus 5x squared by 2 factorial plus in the summation form x to the k 5x to the k over k factorial. Yeah, just that. Yeah, I just substitute 5x into that x, and that's all we have. Of course, another way to do that is construct a table like this, like we did earlier, but that's all we have here. Timestamp. Right. Parametric equation and parameter interval for the motion of the particle in xy plane are given. So this is the equation, parametric equation. Identify the path by finding the Cartesian equation. So from this we find the equation that relate x and y together, and then graph it and indicate the direction. Right. So here we have x equal to 4 cosine t and y equal to 4 sine t, and we need the equation that relate x and y together. Right. So I will write out if x equal to 4 cosine t and y equal to 4 sine t. Right. What we can do is I can square both sides. So that gives us x squared equal to 16 cosine squared t. And then we just add side by side. Give us x squared plus y squared equal to 16 cosine squared plus sine squared forgot the 16 here, right? Or if we can just factor out the 16. Right, we do factor the 16 out. Cosine square plus sine square is 1. So we just have x squared plus y squared equal to 16. So this is of course the equation for circle. Center at 0, 0, I mean center at 0, 0, which is the origin. And the radius is square root of that, which is 4. So this is a circle. Right. A circle. Okay, a circle. Center is at 0, 0. Radius is 4. But we're not done. Cartesian equation is that. But this one we do have the interval here. This is equal to pi and then to 2 pi. So in that case, we will make a table and see what happened. Just put that here. T and then x equal to sine t, x equal to cosine t, 4 cosine t. And y equal to 4 sine t. Right, let's go with 0, I mean pi, 4 cosine pi, cosine pi is -1, so that is -4, and then 4 sine of pi, 0. So we have the point x equal to -4, y equal to 0. That is when t equal to pi. Now we're going to stop at 2 pi, but before that, let's do one point in the middle. So if it is 2 pi, let's just do 2 pi. 4 cosine of 2 pi, cosine of 2 pi is 0. I mean cosine of 2 pi is like cosine of 0, which is 1. And so this is 4. And then 4 sine of 2 pi, sine of 2 pi is 0. So at 2 pi we have this point. Now let's test the point in the middle, 3 pi over 2. 4 cosine of 3 pi over 2, cosine of 3 pi over 2 is 0. And 4 sine 3 pi over 2. Sine 3 pi over 2 is -1. And this is -4. So at t equal to pi, we have this point, 3 pi over 2, and then 2 pi. So the curve actually is going to be this, just the bottom half of the curve of the circle. And it goes in this direction. Right. So, we should check with the calculator. Right, so be careful. There's a lot of different mode on the calculator. So before we use the graphing features, make sure it's in the right mode. We want to graph parametric equation. When x equal to 4 cosine t, y equal to 4 sine t. Alright, and make sure we need to hit the windows, go from pi to 2 pi. And the increment from pi to 2 pi, the interval, the length is 1 pi. I will use pi divided by 100. That means I will graph 100 points from pi to 2 pi. Right. As you see, it goes from here and there. If it doesn't look like a circle, then it should be, because in this case the horizontal, the horizontal axis is, the scale is longer than the vertical axis. So if we want the same scale, hit zoom number 5. Yeah, so that we have exactly the bottom half of a circle. Right, timestamp. Right, parameterization for the curve. For the line segment, the endpoint is here and there. Right, we talk about that in class, the parameterization of a circle. For this, it is much better for the line segment. We just say from t equal to 0 to t equal to 1. Right, so to that end, for that problem, I will make a table like this. When t equal to 0, we have the point -3 and 1. When t equal to 1, we have the point 2 and 3. Right, as far as factor parameterization, what is the formula for that? Okay, so think about this. When t equal to 0, we have -3 and 1 for x and y. So if I write like this, x and y is equal to -3 for x and 1 for y. But that happened when t equal to 0. Now, the motivation for this is just like when we do partial fraction. Let's say we have something like this. If x equal to 5, that one will disappear. If x equal to 2, that is 0, so that one will disappear. Of course, we still put 2 and 5 in here. Yeah, so that is the point. So when t equal to 0, that's why we have this. And when t equal to 1, we have x is equal to 2, y is equal to 3. Right? Okay. Worry about that in a minute. Now, once again, when t equal to 0, x is -3, y is 1. When t equal to 1, x is 2 and y 3. Right, let's go with that. Now, what we need is a factor. Remember, when t equal to 0, that one needs to be disappear. We just have that. So when t equal to 0, these two must gone. So that means we have to have 2t and t. Because now when t equal to 0, that's gone. Right? X equal -3, y equal to 1, when t equal to 0. Now, when t equal to 1, this one have to be disappear. So we need to multiply something here. Alright, now if we're going to put, I'm just going to do that in pencil. If I put t minus 1 here, when t equal to 1, this 2 will disappear. When t equal to 1, those terms disappear and t is equal to 1. So x is equal to 2, y equal to 3. That's one correct. Now, when t equal to 0, this 2 disappear. But that is if that's the case, this will be negative 1. So that doesn't work here, because that would be negative. So instead of put t minus 1 in there, we have to put 1 minus t. Now let's check one more time. When t equal to 0, that 1 gone. T equal to 0, so that 1 gone. We have negative 3 for x and 1 for y. Now, when t equal to 1, this will disappear. And t equal to 1, so we have 2 and 3. So that's pretty much it. And so I rewrite x equal to negative 3 times 1, negative 3 plus 3t plus 2t. Y is 1 minus t plus 3t. Or we have x is equal to negative 3 plus 5t, and y is equal to 2 plus 2t, and t between 0 and 1. Right. So again, that a couple of parameterization. So if we want to go from x naught, y naught to x1, y1, the line segment, one way to do that is x equal to x naught 1 minus t plus y naught plus x1 t. Y equal to y naught 1 minus t plus y1 t, t between 0 and 1. So that is the parameterization of a line segment from x0, y0 to x1, y1, and we used from 0 to 1. Once again, we can check quickly. When t equal to 0, that 1 gone, that 1 gone. Just have x0, y0. When t equal to 1, this 1 gone, and t equal to 1, we have x1, y1. Yeah. Right. And the check, we start with negative 3, and after t is 1, we're going to increase 5 units from negative 2 to 2, and then we start. Glad I checked. This should be 1. We start from 1, and then when t reaches 1, we have 2 more, so 1 plus 2 is 3, so that's correct. Right, so this is parameterization of a line segment. Next, for the upper half of the parabola x plus 2 equal to y squared. Right, so x plus 2 equal to y squared. So if we sketch that quickly, By the way, y equal to x squared is parabola this way, x equal to y squared is this way. However, this will have the plus 2, so we have to shift over here. Yeah, it's like that. Because when x equal to -2, plus 2 is 0, y is equal to 0. So yeah, so parabola that way. And we only want the upper half. So, if it is in this form, it is much easier to solve for x. X plus 2 is y squared. So we can say x is equal to y squared minus 2. Yeah. And then we will say let y equal to t. Then x is equal to t squared minus 2. So the parameterization is x equal to t squared, x equal to t squared minus 2, y equal to t, and t, y have to be positive. The upper half greater than or equal to 0, right? So we want the upper half, meaning y greater than or equal to 0, and y is equal to t. If y is greater than or equal to 0, t is also greater than or equal to 0. Yeah, we can write like that, or if we want to, we can also write t from 0 to infinity. But of course, that one works. Right, so that's what we have for that one. Next, find the slope of the line x equal to 3t, y equal to t plus 3. Well, the slope of the line is given in parametric equation. So dy over dx is dy over dt over dx over dt. dy over dt, this is y, the derivative of y with respect to t is 1. dx over dt, so that is x, the derivative of x with respect to t is 3. Yeah, so that's 1 over 3. That's pretty much it. Probably a little bit too simple. Right, next we will have go from find the Cartesian product for this point. So this is in polar coordinate. We will find the Cartesian product of Cartesian coordinate or rectangular coordinate for that. Let me go to it. Right, so here, that's what we have. Now the asterisk here meaning that make sure that it is in the right quadrant when we do that. Right, but in this case, have x equal to r cosine theta and y equal to r sine theta. This is r, this is theta. So x equal to -5 r cosine of 1 over 2 pi. Pi over 2 cosine pi over 2 is 0. Y -5 sine of 1 over 2 pi. Sine of pi over 2 is 1. So we have the point x equal to 0, y equal to -5. Now if we check that with Cartesian, with the polar coordinate, the radius is -5, r is -5, and the angle is 1/2 of pi. So 1/2 of pi go that way. Instead of go in that axis, in that ray, it is -5, so we go in the opposite direction. So instead of go up, straight up, we go down, and so that point is here. So that's correct. So it's always checked when we convert from rectangular to Cartesian. I mean, rectangular to polar or polar to rectangular. Make sure we graph it and the point are the same. That is very important. All right, next is in the opposite direction. What we have here, this is in rectangular coordinates, so we do have x and y here. Now we'll convert this to polar coordinates, and in this polar coordinate we want r to be positive and angle between 0 and 2 pi. Right, so this formula is what we used earlier. Now we also have from rectangular to polar, x squared plus y squared is equal to r squared, and tangent of theta is y over x. Alright, so it's straightforward. R squared is equal to x squared plus y squared 2 squared plus -2 squared. So 4 and 4 is 8. So r squared is 8. So r is plus or minus square root of 2. However, since we want r positive only, so this square root of 8, positive square root of 8, or 2 square root of 2. Now the angle theta, tangent of theta equal to y over x, y over x. When we're done, just make sure by default should be in function. Right, usually when we do inverse, I prefer to keep things in degree mode. -45 degrees. So the theta, if we write tangent inverse, it is -45 degrees. Or -pi/4. As mentioned before, we should always check and see if it is correct. Original x equal to 2, y equal to -2. So 2, -2, so it is over here, which is correct. Right? So 2 and -2. In polar coordinate, r is 2 square root of 2, and the angle is -pi/2. So yeah, -pi/2 in that direction. So it's work. It's perfectly work. The only problem here, we want an angle between 0 and 2 pi. So we have to add 2 pi to this. So the angle is between 0 and 2 pi. Right? So I'm going to add 2 pi to it. So that is 7 pi/4. Yeah. So just like this, but we go on extra revolution. I mean, go from here. In that. So 7 pi/4. So the point here will be 2 square root of 2 for r, and the angle 7 pi/4. Right. Right. With that, I stop the video here, and then I'll pick it up on the next video. Thank you for watching.